Hi everybody. Today we're going to be talking about lesson 1-7, and this is on page 57 of your math book. So if you're following along on the video here, please be following along in your book as well. All right, so today we're talking all about understanding rates and unit rates. So let's take a look at our first problem here. Luciana ran 4 laps around the track at her middle school in a total of 6 minutes. Suppose she ran at a constant speed. The bar diagram represents the relationship between the number of minutes and the number of laps. So we have 6 minutes and each of the 4 laps in that. The ratio of the number of minutes to the number of laps would be 6:4. Because the units, minutes and laps, are different, this kind of ratio is called a rate. A rate is a special kind of ratio in which the units are different. The ratio 6:4 has the associated rate 6 minutes for 4 laps. We can say it in a couple of different ways. To find the number of minutes per lap, all we do is we take the total number of minutes, so 6 in this case, and we divide by 4 because there are 4 laps that she ran. So we're taking the minutes and dividing by the laps. We then find the lap time. So per lap, when we do 6 divided by 4, we get 1.5. So Luciana ran at a rate of 1.5 minutes per lap. When we get down to that 1, that per lap, right? This is what's called a unit rate. So a unit rate is a rate in which the first quantity is compared to 1 unit of the second quantity. The phrase per is used to describe unit rates. It means for each. So whenever we see per, it means for each. All right, turning the page now to page 58. We could also flip around and do the reverse, and we can find the time how long it takes for the laps and the minutes, okay? So Luciana ran 4 laps in 6 minutes, so we're flipping it. Suppose you want to find out how many laps she can run in 1 minute at this same rate. The bar diagram represents the relationship between the number of laps 4 and the number of minutes 6. 4 laps, here's our 6 minutes, so we're flipping it. Now, instead of taking 6 and dividing by 4 like we did in the last problem, we're taking the 4 and dividing by 6. So if you were to do that, 4 divided by 6, right? 4 divided by 6 is equal to 4/6, which we simplify to 2/3. So Luciana ran at a rate of 2/3 lap per minute. So each of the 6 minutes would be 2/3 of a lap. So here we have a table that summarizes ratios, rates, and unit rates. They're all a little different, but they're all ratios. They're different types of ratios. And remember, whenever we say unit rate, we're getting one of the quantities down to 1. All right, let's take a look at example 1. So this is finding the unit rate. Scientists studying hummingbirds recorded that a hummingbird flapped its wings 1,590 times in 30 seconds during normal flight. Isn't that crazy? Wow, lots of wing flaps. Assuming a constant rate, how many times did the hummingbird flap its wings per second? So one way to do this is set up a ratio table. So we have the number of wing flaps, 1,590, and the number of seconds is 30. Now, if it's asking us to get down to a second, 1 second, right? That's why I need the 1 here. Well, to go from 30 to 1, we divide by 30. And if we divide by 30 on the bottom, we do it on the same on the top. And we found that 53 flaps per second would be the rate at which the hummingbird flaps its wings. Now, the second way, which is a little simpler, a little quicker, less writing to do, I guess, is to set up those ratios, equivalent rates in this case. So set up your 1,590 over 30, and then we're going to have another ratio where we're getting down to 1, okay? So if we do that, right, setting it up, we would then solve for this problem by dividing by 30, same as we did in the table, and find the same answer of 53. Setting it up in the equivalent rates that look like ratios, right, we've done a lot of that, is probably the quickest way to do this, okay? So just know that whatever you have wing flaps and seconds, they need to be on the same line. So let's take a look at the check. The scientists also recorded that the hummingbird took 6,250 breaths over a period of 25 minutes. Assuming a constant rate, how many breaths per minute did the hummingbird take? So once again, when you do this one, you're going to set it up 6,250 breaths in 25 minutes. We need to get it down to 1. So remember, if we're getting down to 1, right, we're dividing by 25. If I'm dividing by 25 here, I'm going to divide by 25 up here. So I can use my calculator and plunk it in, right? 6,250, 6250, and divide by 25, we would get the answer of 250. So they take 250 breaths per minute. That would be our answer to this problem here. All right, let's take a look at example 2. Now, we also deal with this in unit price. So when you go to the grocery store, you will often see this kind of thing. So it says a grocery store sells 6-ounce container of yogurt for 78 cents. The store also sells a 32-ounce container of the same yogurt for $3.84. To determine which is the better buy per ounce, find the unit price of each item. Unit price is the cost per unit of an item. You can use what you know about unit rates to find a unit price. So once again, you can either set up a table or you can set up equivalent rates. All you have to do is divide the price by the ounces if we're looking at the price per ounce. If you do that, here's our 6-ounce container. If we divide by 6, we would get 13 cents per ounce. We would do the same thing with the 32-ounce container, taking the price, dividing by the ounces, and you would figure out that the price here would be 12 cents per ounce. Now, because we're looking for the better buy, in this case, we're looking for the smaller price. So the best buy here then would be the 32-ounce container because 12 cents is less than 13 cents. Let's take a look at example 2. For Carolina's birthday, her mother took her and 4 friends to a water park. Carolina's mother can either pay $130 for a 5-pack of student tickets or $28 each for each individual student ticket. So once again, you need to find the unit price. What would be the price per ticket? But we already know the price for one, the individual tickets. That's fine. So we don't have to do anything with that because we already have the for each here. So we're going to do the same thing though with the pack. So we take that 130, right? The total. If we're finding the price per ticket, we need to get the tickets down to 1. So we're dividing by 5, and we would find that the price here would be $26. Now, which is better, 28 or 26? We're trying to save money here, so we're going to go with the 26. So she should definitely buy the 5-pack of tickets instead of individual tickets. All right, let's take a look at the check here. Same sort of thing. Now, you don't have to set it up like a table. You can set it up like a ratio. Sporting goods store sells packages of 20 baseballs for $25.95. That's 20 baseballs. Or you can buy a single baseball for $1.75 each. So once again, we're getting the baseballs down to 1, which means we're dividing by 20. Do the same thing on the top. Use your calculator. So $25.95 divided by 20 equals 1.2975, blah, 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 right? We can round because we're dealing with money. So this would be $1.30 per baseball, basically, when we round up. Now, $1.30 is a heck of a lot better than $1.75, so we would want to go with the 20-pack. All right, let's take a look at the apply problem. There we go. The Martinez family and the Davidson family each drove at a constant rate. The Martinez family drove 260 miles in 4 hours, and the Davidson family traveled 305 miles in 5 hours. Which family traveled at a faster rate? So you need to get each of these down to 1. So remember, 1 hour, when we do that, 260 in 4, so this is the Martinez family, we need to get that down to 1. So to get that down to 1, we're dividing by 4, right? The Davidson family, 305 in 5, getting that down to 1. So use your calculator. It's always okay. 260 divided by 4. Oops. Apparently I'm faster than my calculator. Let's try that again. 260 divided by 4. So their rate was 65 miles per hour. The Davidson family, 305 divided by 5, was 61 miles per hour. So which one was going faster? Now remember, when we're finding speed, whichever is higher, right, they can go further, okay? So we know then that the Martinez family was driving at a faster rate, and we can take 65 and subtract 61, right? And we would know that the speed would be 4 miles per hour faster. So they were traveling at a faster rate and by 4 miles per hour. Okay, so please remember to complete your homework online. If you have questions, please contact me and I will be happy to help you on anything. Do your very best work. Make sure to be checking those answers, and we will see you later.